I was asked to be at this talk probably like a month ago, and when I heard the name of the talk, Transport, Travel and Our Planet, I thought, okay, with the bad press that aviation has now, how am I going to speak about something that is sustainable on our planet? So well, I've done some research, and I will tell you what's being done currently within Rolls-Royce and within the sector to actually address that. So Rolls-Royce, you probably are familiar with the brand. It's no longer a car manufacturer. We're mainly focusing now in pioneering the power that matters. What is that? We're actually going through a massive transformation to actually believe, so go through the positive of the transforming the potential of technology in all different fields of aviation, transport systems, but also finding the new technologies that, as Vijay mentioned, will make our industry as carbon neutral as possible. So we're actually pioneering the power that matters to connect society, be it by land, by sea, or by air. We love solving complex problems, and I think that is a key theme within engineering. So if you like problem solving, engineering is definitely a career to actually think of. Because it not only involves mathematical and physical complex problems, but also how dealing with new challenges and new technologies. At the moment, as Vijay mentioned, I think the greatest challenge our society is facing is how we can find the next generation of technologies to deliver the lower carbon power, so means of transport. And actually, Rolls-Royce is undergoing its way to deliver, so to become the world's leading industrial and technology company that actually delivers those technologies and those solutions. How are we going about it? We're actually, we have a crucial role to play as a company, because we actually need to transform one of the biggest sources of actually generating emissions, as Vijay mentioned earlier, from air transport, and actually find cleaner, more sustainable and scalable ways of generating that power for the aviation industry. So I'm going to talk to you about 3 different strands that currently my company is working on to deliver those new technologies. But if you know about, so the European Commission has set the industry a challenge that by 2050 we reduce our carbon dioxide emissions by 75%, and also our nitric, so the emissions from nitric oxide and nitrate dioxide, which actually are produced from burning fuel in aviation, by up to 90%. The key challenge we have is we don't know yet how to do it. So there's millions of people around the world working in developing those technologies that will be able to meet those targets or come as close to them as possible. So one of the things I've actually been working on since I joined the company is actually making engines that are more efficient, burn less fuels, and therefore they actually produce less emissions. Why is that important? If we think, well, for example, there's Greta Thunberg is actually now traveling across the Atlantic Ocean using a catamaran to prevent flying. I think in a realistic way, not everyone can make those travel choices, and especially if you want to travel long distances to connect people, let's see, family, relatives, we're becoming a society that is much more global, and you will have the need for maybe, yes, going on holidays or visit people you're connected with, to travel long distances. And let's be honest, at the moment, the fastest way is the air aviation. So I think our role within that is to become more efficient. And also, if we think about medical emergencies where world lead class surgeons will need to fly to the other planet to actually be key roles within a surgical procedure, or let's think as well organ transplants. How are you going to transport an organ from one side of the country to another if you don't do it by air transport? Sometimes those aspects of air aviation are actually not mentioned, and I think they're key to actually consider. We can't just all not fly. Another of the key technologies that we're developing within Rolls-Royce is the UltraFan engine, which actually is a geared turbofan. So if you think of the concept of jet engines, we actually suck air, we squeeze it and we compress it as much as we can. There's a big explosion in the combustion chamber where we actually burn the fuel, and that drives the turbine. The problem with that is usually the fan has to spin at a different velocity, so it has to spin at the same velocity as the turbine is doing. The beauty of the ultrafan is that we have installed a gearbox that actually changes the fan from the turbine and allows each of them to run at the best at the best speed, the optimal speed for each of them. That is a massive saving in actually fuel consumption. And this technology is being developed by multiple manufacturers in the aviation industry. And it's also scalable, so you can use it from a commercial single aisle flight for long distances, but you could also use it in transatlantic. One of the challenges this technology is facing, as Vijay was mentioned earlier, is how can you ensure we have the regulations to keep these means of transport as safe as possible, because we're facing new challenges. So for example, the ultrafan compared to the Trent 700 uses up to 25% less power, which translates as well in a much higher reduction of emissions. Another thing we're currently working on is actually the eFan X, which is actually a technology demonstrator that actually is exploring the possibilities of electrical flights. I should say hybrid electrical flights, because imagine what would happen if your only electrical powered airplane would run out of battery in the air and you have no station up there where you can actually charge it. So that's why we're actually looking at combining current fuel and electric generation to actually not be as clean as we can, but at least meet the target to actually do it. So this is actually based on an air platform called the WhisperJet, and it has 4 engines, and one of them has actually been replaced by a fan and an electrical motor. You also have a Rolls-Royce powered engine in the fuselage at the back that drives a 2 megawatt generator. And the research is actually aiming to understand the thermal effects, how we manage power, and also the electromagnetic issues you have during flights. We're optimizing the power generation and the usage in all phases of flights by actually the same as a hybrid electric car would do, that actually drives on fuels at the beginning and then runs with the battery, is the same with the aircraft. You actually can adjust who is giving you the power. Is it the electrical motor, or is it actually the kerosene that is stored in the wings? The challenges these technologies are facing is actually boosting power efficiency from the same weights. Weight is always key for aviation. As Vijay mentioned, if we replace passengers for batteries or for generators, we're not meeting the needs of actually transporting as many people as possible as far as they can reach. Another key challenge is how can we ensure that these new aircrafts are as safe as they possibly can be. And regulators are very skeptical about new technologies each time we introduce them. We don't have the rules at the moment to actually ensure that these planes can fly, so there's a big package of work that is undergoing with the policymakers and the different certification authorities to understand and develop new rules. Another big stream, which I'm actually really passionate about, is developing biofuels. So the beauty of biofuels is that you can manufacture them almost everywhere. They're affordable, and also because you're actually growing plants that through the photosynthesis, they're removing CO2 from the atmosphere, so they're actually offsetting the emissions that you're actually then getting through the means of transport. This is a really beautiful route to actually reduce the greenhouse gases that we have in the atmosphere. But at least for the engine, so the jet engine industry, we have to optimize the components we have, the fuel systems, the combustion chambers, because the fuel will have different properties and different kind of emissions. So we have to adjust our motors to actually be as compatible as possible with the next generation of fuels. It is a big challenge to actually be as close as possible as the properties kerosene has for the aviation industry because of its high power density and also because of its properties. If you think that most of the time these fuels will be at 30,000 feet above sea level, where it's extremely cold, and some of them, they actually become solid at those temperatures. So one of the most promising biofuels for those key requirements is actually the synthetic kerosene, which is actually being developed through a very interesting process and is at the moment being tested, mixing kerosene and synthetic kerosene to understand its properties. You can, because it's something you're generating synthetically, you can optimize it for the properties of flights you're going to use. So it will be different from short-haul flights to actually long-range. I'll go down from Rolls-Royce to a big corporation to actually speaking to you a bit of how I ended up working in the aerospace industry, and to actually present you with an example of what's a career in engineering. So, as you probably have guessed from my name pronunciation, I'm not British. I'm originally from Spain. I studied aerospace engineering in Madrid, and I've had quite a varied career. I've been working at a research institute in fluid dynamics in Brussels. I've worked for Siemens in Germany in their energy division in renewables energies, and I've been working with Rolls-Royce for about 7 years now in mainly the civil large engines division. So I think key messages I would like to actually share with you from my career is that I would make a career choice based on what you're passionate about. I knew since I was 15 that I wanted to study aerospace engineering because I was passionate about maths, physics, and the idea of flying, of connecting people. And also, when I chose my degree, or when I chose my first job, I was so afraid of actually making a wrong choice. But there's never something like a wrong choice. You'll always learn something from the decisions you make, and we'll always change. So I think our generation will change from one career to another, or from one sector to another, and that's the beauty of the times we're actually living. So thank you very much.